Solve the following system of linear equations. X minus y plus 2z is 3. Z minus x plus 2y is 1. Y plus x plus 3z is equal to 6. I can solve this system using the method of substitution or the method of elimination or a combination of both of these methods. I am going to solve this system first using the method of substitution and then using the method of elimination. First, the method of substitution. Choose any of the equations and isolate any variable you would like in that particular equation. Let me number my equations. Equation 1, equation 2, and equation 3. This is the first stage of the problem. I have 3 equations and I have 3 unknowns. I can choose any of the equations and I can isolate any of the variables. It is, however, preferred if we isolate a variable in a way that we do not create fractions in order to avoid more complicated algebra. In this case, I am going to choose equation 2 and I'm going to isolate z. Equation 2 says z minus x plus 2y is equal to 1. I can move minus x to the right hand side and also 2y to the right hand side. To isolate z, z becomes plus x minus 2y, and there was a plus 1 on the right hand side. I call this equation 4. Now sub this expression for z in the remaining equations. Let's look at equation 1. It says x minus y plus 2z is equal to 3. If I use equation 4 and plug in for z into this equation, I get x minus y plus 2z, x minus 2y plus 1 is equal to 3. This equation involves x and y only. I can simplify this to get x minus y plus 2x minus 4y plus 2 is equal to 3. I can simplify this further to get x plus 2x, 3x, and then minus y and minus 4y, minus 5y. The 2 can go to the other side. 3 minus 2, or 1. I call this equation equation 5. We found equation 5 by plugging in the value of z, in fact the expression for z in terms of x and y, into equation 1. Now we plug in the expression for z in equation 4 into equation 3. Equation 3 says y plus x plus 3z is equal to 6. If I plug in the expression for z from equation 4, I get y plus x plus 3 times z, which is x minus 2y plus 1, is equal to 6. This equation involves only x and y. I can simplify this equation further. Y plus x plus 3 times x minus 6 times y plus 3 is equal to 6. And if we add the terms properly, x plus 3x, 4x, then y minus 6y minus 5y, you can take the 3 to the other side of the equation. It becomes minus 3. So you would have on the right hand side 6 minus 3, which is plus 3. I call this equation 6. Let's put equations 5 and 6 together. Equation 5 says 3x minus 5y is equal to 1. And equation 6 says 4x minus 5y is equal to 3. I call this stage of the solution stage 2. In stage 1 we had 3 equations, 3 unknowns. In stage 2 we have 2 equations, 5 and 6, and 2 unknowns, x and y. We can apply the method of substitution to reduce this system, the 2 by 2 system, to a 1 by 1 system, one equation involving one variable only. Once again, we repeat the iteration. Choose any of the equations, 5 or 6, you like, and isolate any variable you like. Try to isolate a variable in a way that you wouldn't create fractions on the way. In this example, I'm going to choose equation 5. And I'm going to isolate y. Equation 5 says 3x minus 5y is equal to 1. I can take minus 5y to the right hand side and bring 1 to the left hand side. I would get 3x minus 1 is equal to 5y. I can divide both sides of this equation by 5 to get y is equal to 3x minus 1 over 5. I call this equation 7. Now sub this into equation 6. Sub y in equation 6. Equation 6 says 4x minus 5y is equal to 3. If I plug in the value from equation 7, I would have 4x minus 5 times y, which is 3x minus 1 over 5 is equal to 3. As you can see, we have one equation involving one variable only now, and this means we can find the value of that variable. Let's proceed further. The 5 here and the 5 in the denominator cancel out, and if you simplify the equation, you would get 4x minus 3x minus 1 is equal to 3, which you can simplify further to 4x minus 3x plus 1 is equal to 3, which simplifies to x is equal to 2. Once you have one of the unknowns, it is very easy to find the other unknowns. Sub x equal to 2 into equation 7. Equation 7 says y is equal to 3x minus 1 over 5. If we substitute x equal 2 in this equation, we will get 5 over 5, which is 1. The value of y is 1. Now sub x equal 2 and y equal to 1 in equation 4. Equation 4 says z is equal to x minus 2y plus 1, which becomes 2 minus 2 times 1 plus 1, which becomes 1. Therefore, z equal to 1 is the answer to this equation. Here is the final conclusion. The solution to the system of equations is the point 2, 1, and 1. Now let's look at the problem using the method of elimination. In the method of elimination, decide to eliminate one variable. You can choose any variable, but it is better to choose a variable which is easier to eliminate. I choose x in this example. I decide to eliminate x from the 3 equations that I have. I pair equations 1 and 2. They read x minus y plus 2z is equal to 3 and z minus x plus 2y is equal to 3. I observe that if I add these 2 equations, the term x will cancel on the left hand side. Let's add these 2 equations. 1 plus 2. We would have minus y plus 2y, which is plus y, 2z plus z, which is 3z, x minus x, which is 0, is equal to 3 plus 3, which is 6. I call this equation equation 4. It does not have an x term in it. Now I consider equations 2 and 3. They read z minus x plus 2y is equal to 1 and y plus x plus 3z is equal to 6. Once again, I observe that by simply adding the 2 equations, I can get an equation which does not involve x. Let's add equations 2 and 3. Z plus 3z is 4z. Y plus 2y, that's 3y. Minus x and x, 0. And then 1 plus 6, that is 7. I'll call this equation 5. Equation 5 does not involve x either. Let's now pair equations 4 and 5. Equation 4 reads 3z plus y is equal to 4. And equation 5 reads 4z plus 3y is equal to 7. If we would like to continue with the method of elimination, we would need to combine these two equations in such a way that one of the variables is eliminated. In other words, we combine these two equations in such a way that we get a third equation that does not involve one of these variables, z or y. I would like to combine these two equations in a way that I do not have y in the resulting equation. I multiply the first equation by a minus 3. This is because I would have minus 3y in this equation, which when added to the second equation would cancel out with 3y. So I multiply the first equation by minus 3. Minus 3 times equation 4. This means you need to multiply minus 3 into every term in that equation, into 3z, into y, and into 4. If we continue, we find that minus 9z minus 3y is equal to minus 12. This is equation 4. Equation 5 is 4z plus 3y is equal to 7. Now if we combine these two equations by adding them, we get minus 9z plus 4z, which is minus 5z, and then minus 3y and 3y, which give us 0, is equal to minus 12 plus 7, which is minus 5. We now have one equation, one variable. We can solve that equation for the variable. If we divide both sides by minus 5, we see that z is equal to 1. We can now sub z equal 1 in equation 4, for example, to get 3 times 1 plus y is equal to 4. The original equation was 3 times z plus y is equal to 4. We can now simplify this to get y is equal to 4 minus 3, or y is equal to 1. We can now sub z equal to 1 and y equal to 1 in, for example, equation 1, and we would get this is the original equation. We would get x minus y plus 2 times 1 is equal to 3, which we can solve for x to get x is equal to 2. Therefore, the solution to the system of equations is the point 2, 1, and 1.